Welcome to Pure Mathematics 1, Chapter 7, Trigonometry. Topic: Solving equation using graph, a trigonometrical function. And let's say if you have a cos of an angle 60 degrees, it could be 0.5. But when you want to find the angle x, we have cos x equal to 0.5. You have an infinite number of solution. So please look at this one. You have a lot of number like this. But why, when you enter the equation cos minus 1 of 0.5, which is the inverse of this one, in order to find the values x, it only appears 60 degrees. So why is that? And now we will look for the principal values in order to understand why when you enter the equation cos minus 1 of 0.5, we only have one value, which is 60 degrees, not minus 60 degrees or 300 degrees or 420 degrees. From the previous example, you know that when you have the value cos x equal to 0.5, you have an infinite numbers of solution. So we know that it is a one-to-many mapping. But in order to make it is a function, we have to convert it back to one-to-one mapping. One-to-one mapping. So for each type of graph, we would need a principal values to restrict them back to one-to-one mapping. So for the graph of the cosine theta, the theta in this case would be restricted to from 0 degree to 180 degree. When you enter a number from any number from minus 1 to 1, you will have your values in your calculator ranging from 0 degree to 180 degree. Let's say you have minus 0.7, which is this one. So your value will be in here, in this point. And for the sine theta function, you will have your principal value ranging from minus 90 degree to 90 degree. So for any values from 1 to minus 1, when the sine theta can be equal to, it will take a value from minus 90 degree to 90 degree. For the tan function, tan theta, we have our theta ranging from minus 90 degree to 90 degree. But it will never be equal to, so we have only greater in here. So here's the other value that you are going to receive when you enter the equation. For this one would be cos minus 1 x equal to, and this one would be sine minus 1 x equal to, and this one is tan minus 1 x equal to. Your values, all value in the 3 points here, here, and here, will range from the principal values that they are given in the calculator. And now we're going to solve this equation. And here you have solved the equation to sine squared of theta equal to cos theta plus 1 for theta ranging from 0 degree to 360 degree. So first of all, let me rewrite the equation. 2 sine square theta equal to cos theta plus 1. So now I have sine square theta, but I know the identities. Sine square theta plus cos square theta equal to 1. So I would use this one in order to make all in here is cos, no sine here. So I have 2 multiplied by 1 minus cos square theta equal to cos theta plus 1. And now I have 2 minus 2 cos square theta equal to cos theta plus 1. So I will move them into one side. I have 2 cos theta cos square theta plus cos theta minus 1 equal to 0. And now I want to factorize this one. Now I have 2 cos square theta plus 2 cos theta minus cos theta minus 1 equal to 0. I will have 2 cos theta multiplied by cos theta plus 1 minus cos theta plus 1 equal to 0. So I will make the cos theta plus 1 into the subject equal to multiply by 2 cos theta minus 1 equal to 0. So I have two possible options. Is it cos theta equal to minus 1 or cos theta equal to 1 over 2. Here's minus. When I enter this equation into the my calculator, I have 1 will be equal to 180 degrees. As such, this defines the range from 0 to 360 degrees. So I have one value, which is this one. Okay. But then I substitute this equation into here. 1 over 2. I have my value is equal to 60 degrees. But now I wonder that whether I have any more values in here. So I would sketch a code graph. I sketch a code graph would be this one, ranging from here to 360, 0. And I have my cos theta equal to 1 over 2. So I cut this one here. I have two intersection. So I just found one, but the other one, how can we find it? Because you know that here is 90 degrees. I have my value 60 would be this one, the first solution. I found it by using the calculator. So now I want to find the values of this one in this point. So you can see that this distance from 0 to this one is 60 degrees. This distance is 60 degrees. It's also the same distance from 360 to that point. So in order to find my third values, I would have to take my third value, theta equal to 360 degrees minus 60 degrees, which is equal to 300 degrees. So this one is my third value. For this type of question, I recommend you to draw a graph in order to illustrate where is your root, and you see how many roots that you need to find, and it will be easier for you to calculate these things to find the other root that you need to calculate.